You know, at first, sounded like a good idea, but in practice, not so much. When browsing the internet, you may have come across these Teflon coated lead screws. And when you think about it, it kind of makes sense, especially if you're combining that lead screw with a palm lead nut. That is to say, a lead nut that is made from a material known as POM. I mean, you take a lead screw that's coated with a material that's designed to be very slick, non-stick. You use it on your pans when you're cooking stuff like your eggs because it's got a relatively high lubricity to it. And couple that with a nut that is made from a material that is considered to be mostly self-lubricating due to its physical properties. And you can create one that is a bit tighter on the threads because of that. Sounds like a match made in heaven, but we're going to talk about why this setup, well, let's just say all that glitters is not gold. You'll have to excuse my ever so messy work table, but we're going to talk about the reasons why this isn't actually so great. Now, this is a normal lead screw. It's probably cold rolled, not machined. It's probably not the most accurate motion control device in the world. I mean, it's not going to outclass like a high wind ball screw or anything like that. But it gets the job done, and it does it for a relatively cost-effective manner of speaking. But when we start to pay about twice as much for a lead screw that's Teflon coated, we need to talk about its cost-effective nature and the problems that come along with it. So let's get to it. Let's just take a minute to appreciate how this works. You have some threads that a lead screw nut moves up and down on when these shafts, these lead screws rotate. Now, the amount of rotation is important because our 3D printers usually work on a principle of about 0.04 millimeters of movement per step of the stepper motor, at least with an 8 millimeter, not pitch, but an 8 millimeter lead on a lead screw. Now, here's where things start to become a problem. You need that mechanical movement, that rotation, and that movement of that nut to be pretty consistent throughout the entirety of the lead screw. And when you start applying a coating to the lead screw, well, guess what? You can't ensure a perfectly even coating throughout the lead screw, which leads to artifacts in your prints. You ever try to deal with a problem like Z-banding and you adjust everything and you just still can't get it right? Well, that was my life for a few days, and when I switched back to my non-Teflon coated lead screws, the problem went away. So I started to think, I wonder what happened there. Well, I looked at the specs of these Teflon coated lead screws, and the Teflon coating ranges anywhere from 2 to 4 mils according to the manufacturer. Now, if for reference, in case you're wondering just how thick 4 mils is, the thickness of a piece of paper is approximately 4 mils. Now, that's not very thick. It's a piece of paper's thickness. But again, when your resolution on something like an Ender 3 with stock lead screws and stock motors is 0.04 millimeters, 4 mils actually does make a difference, especially when it's not 4 mils consistent throughout the lead screw. It's anywhere from 2 to 4 mils, and that is where the problem starts. Believe it or not, that's not where it ends, though. It actually gets worse. We need to talk about those palm lead screw nuts for a minute here. Now, palm is a really cool material. If you ever get a chance, just spend a little time looking up this stuff. It's a nightmare to print with, but if you're going to injection mold it or something like that, it's probably not nearly as bad. But there's a concept behind this, palm being a material that, well, if it's palm-on-palm contact, it's at least considered self-lubricating in its own special kind of way, but palm-on PTFE, or Teflon, in other words, should provide enough lubricity that you don't need to add supplemental lubrication like white lithium grease or super lube or anything like that. So, it sounds like a good idea, but when they make these palm lead screw nuts, they're more or less making them almost a freaking straight up negative off of these lead screws, which, sounds kind of neat at first. You get a really tight tolerance between the threads of the nut and the lead screw, which is a bit different compared to something like a traditional brass lead screw nut, which has to be tapped and has to have threads cut out for it. And there needs to be a little bit of movement in between the threads of the lead screw and the lead screw nut so that it can move. But I think whoever started manufacturing these kind of overestimated the capabilities of the lubricity properties of these two components, because man, oh man, let me tell you what, not every lead screw and lead screw nut is going to be the same. For instance, these two lead screws right here have vastly different diameters compared to each other, despite from them being the same manufacturer, same product spec, and yet when trying to thread these on, you can feel the resistance. In fact, I had to induce a little bit of, I don't know, let's call it a run out in these nuts myself by attaching this lead screw to a drill so that I could turn the lead screw in the nut a little bit to wear away a tiny gap so that I could even use these lead screw nuts to begin with. They were that tight. And the thing is, it's probably not the nut's fault, it's the application of Teflon to these lead screws. It's not even, it's not guaranteed, and in a system with dual Z rods on your Z axis, meaning you're using two of these lead screws, one on each side for your Z axis, if they are not the same, you're gonna get printing artifacts in your prints. Mine showed up in a variety of ways, but most notably some very strange Z banding that I really hadn't seen before. So after troubleshooting for days and days and days, and yeah, I'm not joking, I really did troubleshoot for days trying to give these things the best shot they possibly could. Man, I tell you what, it just wasn't worth the headache and the never-ending problems that I got from this uneven coating of Teflon. So, lesson learned. Sometimes the traditional way of manufacturing things is probably there for a reason. Look, it's cool to try and advance the technology, but buddy, this ain't it. At least not for me. So, I mean, again, short video. I hope I got the point across, but yeah, maybe this isn't quite the way to go. I've had tremendous success with the standard, let's just use brass on stainless steel or something like that and use a little bit of lube to make sure everything moves smoothly. That's been working great for years. It's been an industry standard for heck, who knows how long now. But I got to applaud the companies trying something new. Just swing and a miss, guys. Swing and a miss.